Good afternoon, all. Microservices and Redis, a match made in heaven. So, just before starting the presentation, a little bit about myself. My name is Vijay Vangapandu. I'm software architect. I'm working for eHarmony. I've been with eHarmony a little over 8 years. I have experience working with distributed systems, big data systems, and especially with the microservices architecture-based systems.
The big question is, are you married?
Yes, I am married. I have 2 kids. Okay, so how many of you know eHarmony? Heard of eHarmony? Well, everybody knows, right? It's a very well-established brand. So who is eHarmony? If some of you don't know, or just for the benefit of this presentation, I'll just go over who we are. So eHarmony is a leading dating site which primarily focuses on long-term relationship. I'm going to explain you how we are doing that. So basically, we achieve that by asking you series of questions that we call it as relationship questionnaire. That is key for our service. With that, with the answers to those questions, we calculate 29 dimensions and factors. Those dimensions and factors are key for our compatibility models. We use compatibility models and few other models to generate the matches between the users. We generate 15 plus million matches per day globally. That number varies depending on the time, depending on the user pool. So far we have 20 plus billion. That 20 plus, this slide is a little bit older, but the 20 become like a 22 plus billion matches in our system today. We have about 100 plus 1,000 photos uploaded per day, and then 1 million communications, 1 plus million communications per day. That is a key metric to track. So what is the core product? As you know, eHarmony is a matchmaking business at scale, right? So at core, our compatibility models are very core business models. So compatibility takes care of whether you are compatible with the other person or not. So the compatibility, as I explained in the previous slides, there are 29 dimensions and factors. Some of them are humor, adaptability, passion, and all those things. So when you answer all these questions, we calculate these factors and then use these factors to match with the other people based on the score. Next, affinity. The affinity is different. The compatibility just tells you like you both are compatible because your personalities are same. It doesn't mean that you both go along, or it doesn't mean that like you both will start the communication. For a successful dating, for successful date or successful relationship, communication is another important factor. So the affinity will take care of like how likely you both will end up in the communication, how attractive you both are. So that's what the affinity model is about. And then finally, distribution. So the distribution is key factor because we don't deliver all your matches in one day, right? We have to deliver few matches per day and make sure that like you are successful. We have to guide you through the process. The distribution will take care of it. It's not only that we are giving you the matches. Let's say a match limit of 10, like we'll give you 10 matches. We have to make sure that in the entire graph, right, you are getting 10 matches, which means like you are given to 10 other people. It's a match, it's a graph problem. So the distribution is take care of that graph problem. So again, compatibility, this is basically like we calculate those factors. Based on those factors, how many other people are within your range, are like are compatible with these factors, right? And then we call them our pairings. They are not matches yet. We call them as pairings. So when you sign up, we call it as onboarding. When you sign up, we ask series of questions. Those questions are ranged from compatibility related questions, affinity related questions, which is about like you are physically fit, are you attractive or not, and all those kind of questions. Self-selects. It's not only compatibility, but also we respect your self-selects. You can say like, I drink, I only want people who doesn't drink, or I only want people who doesn't smoke, or within a certain distance. And all these things are called self-selects. We have to respect them. And then finally, profile. When you interested in somebody, you want to know more about them, right? That's about the profile. So this is the core product experience. I mean, we have so many other features, but these 4 are like fundamental. After you sign up, we deliver the matches to you. You have a match listing space. You can go and see who your compatible matches are. If you're interested, you can open the match profile and go through all the details, common interest, compatibility scores, and everything. And finally, if you're interested, you can start the communication, and you can see the activity. Apart from that, there are other small features, not small features, significant features, like what if. What if is basically, it's not only what we generate matches for you, there are pairings. If you're interested, you can go and see who's compatible, or they might be not within your self-select range. You might say like, I want people only within like 10 miles. If they are not within the 10 miles, there are great people outside of your 10 miles. But you said like only in 10 miles. But we said like, what if you just remove that restriction? You have other possibilities. So that, like that, there are so many features, right? Okay, so as you can see, there are so many dating sites, right? So the dating industry is very competitive, right? So we have to be, in order to be in the competitive, we have to be very innovative. We have to push more features to users. We have to test more features, right? And we have to reevaluate our models, and we have to make them better every time, right? So our product always tries to push more features, more frequently, and they wanted to do more tests, right? So how can we do all these things, right? We started back in 2000, right? It's been almost 18 years. Like any other site who started in early 2000s, everybody starts with a monolithic web application. So it has its own set of problems. You can't move fast, right? So then microservices. So we started back in 2009, we started pulling services one by one out of our monolithic web application. At that point, we called it a service-oriented architecture, right? Microservices was not popular back then. So then it helped us, and eventually, I think we started microservices, adopting microservices patterns in 2014, as early as Netflix came up with like, hey, these are the microservices, cool or whatever. That's when we started this. So by now, you might have read hundreds of blogs or videos or presentations about microservices. You go to any presentation, if they don't talk about microservices, something is wrong, other than big data platforms, right? So I'm not going to spend too much time here because you all know this thing. Benefits of microservices, developer independence. This is very, very important thing. You're not locked down. If you wanted to upgrade, you upgrade. If you want to use something which is cool, you use it, right? You're not impacting other people. Isolation and resilience. Since microservices is a single independent component, if you design it properly, we're going to talk about those pitfalls. If you design it properly, you are not impacting the other people. Scalability, you can scale each and every service independently. For example, for us, a popular page is my matches page, right? If we are in the one monolithic web application, I cannot scale just my matches. I have to scale everything, right? So then, relationship to the business. Business nowadays, there are so many product owners. Each product owner is responsible for certain feature, right? So they don't need to compete each other to release which one to go first, right? They can go on independent. They can release on their own phases, right? So today, just before going to our use cases, just before going to the microservices, what it did, this is what's happening today. At eHarmony, we release so many services. This is day before yesterday. You can see so many services got released, and there are so many. I can't fit all of them in one screen, but it is happening today. That is automatic. So the different product managers manage different verticals, and then they push the code at different times. They don't need to worry about who's impacting who, because they're all independent component. Now let's talk about our eHarmony microservices architecture. Today we have little over 100 microservices in total in eHarmony, and they are growing. So microservices architecture, it is great. You'll get more flexibility. But the problem is flexibility comes with a little bit complexity as well. You have a maintenance problem. If you don't design it properly, you have a maintenance problem. Today, I'm not going to talk about those maintenance problems. Today, I'm going to talk about microservices, how we implement it. Especially, there are so many things to cover in microservices. You can talk about containerization, how you are deploying seamlessly. You can talk about service discovery. You can talk about circuit breaking. You can talk about fault tolerance and all those things. Or you can talk about monitoring. I'm not going to talk about all those things today. Today, I'm going to talk about persistence layer, decentralized data governance. So there are two important things here in the microservices: decentralized service governance, decentralized data governance. So let's talk a little bit about decentralized service governance. Then we can move on to the decentralized data governance. Then we can talk about how Redis helped us achieve that. Okay? So at very high level, we have gateway. Gateway is responsible for authenticating and authorizing the users. No, authorizing the users or authorizing the API calls, just to say. So at very high level, users have to log in. We have 4 platforms: Android, iOS, mobile web, and desktop. They log in. When they log in, we give a token. That token is stored in the session store. Along with that token, we store a bunch of other informations like your authorization, your permissions, and everything. So from that point onwards, users have to come with that authorization token. We implemented it using the OAuth 2. The public API, we implemented our own public API gateway. If you talk about like Node.js, which is a single-threaded, right, non-blocking I/O. So we implemented this using JAX-RS Jersey 2 async responses. It is multi-threading, non-blocking I/O. So at very high level, calls comes in, we pull the token from the Redis, we see whether authorized or not. If it is authorized, we let it go through. The next layer is aggregation service. So one important thing to consider is in microservices, the monolithic, everything is in one box, right? Everything is in memory. One call, you do everything and you give it back. With the microservices, you decomposed, which means like decoupled, which means your services, you have so many network calls, right? In order to reduce the number of hops, in order to reduce number of network calls. For me, network is always black box. I don't know. I mean, as a programmer, for me that like, okay, there is a failure, there is a failure. So to avoid multiple calls from the outside, what you can do is you can have a thin layer of like aggregation. All it does is like, it doesn't interact with any data store layer. It just interacts with other services through HTTP calls or anything, right? HTTP calls, aggregate the data, give it back. This is where we are leveraging reactive programming. If you know, it's a Java RX, okay? We use the Java RX. It's basically observable pattern implementation. We span the calls to multiple services. We gather all that data. We combine it and send it back, aggregate it, send it back. So one important thing to consider here, failures will happen. When you say like, go and fetch data from like 10 services, there might be failures. Or if one service is suffering, you should not suffer the entire response time. So think about the partial responses, 206, right? So that's your best friend. So identify for this page or for this API, what is important. That you need to have, it's a mandatory. If that fails, call failed. Let's say you have some supplementary data. I need to display some ad here, I need to display some other content here. Even if I don't get that content on time, I can live with it. Just put a aggressive timeouts and then just give the 206, right? Just don't suffer the response times. That's the responsibility of aggregation service. Now the next layer is core services. That's what are responsible for maintaining your data or like a data management, right? So you want to save the profile or retrieve the profile or you want to save the photo and all that, all those calls will be handled there. So next layer is your persistence layer. Now let's talk a little bit, I think in the next slide I'm going to talk about the communication flow between the services and within the vertical. So if you look at this article, the first blue box, it's all front-facing microservices and then separated by a message bus. And then the bottom, you have our matchmaking system, which is both supports online and offline batch system. They both are separated by message bus, and there are HTTP calls as well. I did not represent those things, but there are HTTP calls. Now let's talk about the typical communication flow in microservices. So you have public API. API call comes in. Let's say user want to communicate with other match. They send the communication. Now I have to record that fact that user wanted to communicate, right? I stored it in the primary data store. Now I need to mark that hey, match, now it's no more in the new state. The state got changed to communication. Now I need to update the matches section. Otherwise, when you go to the my matches page, that will be pulled as part of the new, but that's not a good state, right? And then I need to say like, hey, you got one communication, so I need to increase the count of your badge, right? So I need to do all these things. If I do all these things in the same time, you have problems, right? So avoid that. If at all possible, avoid that. Don't try to write into services parallelly. Avoid the communication across the services, horizontal communication. But how can you do that? Instead of that and that, do the event sourcing. Event sourcing is send an event, right? Consume that event wherever you want. That's the event sourcing. Now, how can you do that? This is where the data decentralization comes into the picture, right? Now, if I only keep that communication data in that primary store, right, this is not possible. Now I have to put that same communication data, not the entire communication data, but part of that communication data in other services as well. In this case, matches contains the communication state. Badge contains the communication count, right, like that. So this is called denormalized, or in early implementations, we used to call it as a presentation ready feed. Hey, we will take care of all the updates background, but when user asks for something, I just pull that feed from the store and I'll serve it. That's how you will achieve low latency response times. For us at eHarmony, we have 100 to 150 milliseconds for the reads as SLA and 150 to 300 milliseconds for the writes, except certain external systems. Like if you wanted to talk to CyberSource for like, payments or, iTunes, you can't predict those response times because you are depending on the external systems. Other than that, whatever we build, that's in mind. Because as eHarmony is a subscription service, availability and response times are key factors for the user experience. We can't live without that. Any service we design, we have to keep those things in mind. So how can you do that? How can you do that? Like, response times, it's not that easy, right? It's not that easy with that scale, right? So that's where the data, decentralization of the data comes into the picture. As I said, like you denormalize data, put it in different services. Now, it is more fault tolerant, which means one vertical, if something happens to one vertical, is not impacting the other vertical. In other way, services are independent. If service has any problem, if the store has any problem, only that feature is down, not the entire site is down. So another thing, these stores needs to be fast. And it's a polyglot. I can use anything I want. It's depending on my use case. I don't need to use the joins. I don't need to have queries and everything. Now I'm not locked down to SQL. I'm not locked down to Oracle. I can choose my store. That's what we did. We have different NoSQL stores. Every service has different. I'm not saying use different NoSQL stores, but you don't. My suggestion to you is don't go crazy. Don't go too many things. It will create the maintenance problems. But what I'm saying is a few different kinds of data stores, right? And if one data stores all your problems, stick with one data store. If it is not, don't get restricted by that. Go for secondary one, right? That's what my suggestion. So we chose Redis for few services. I'm going to talk about those use cases in next slides. And then we also use other data stores. I'm not saying Redis is the only data store we use, but Redis is the primary key data store as of today for us, right? We use other data store like MongoDB, HBase, and other stuff, but it's for a different use cases. Okay, what is Redis? I'm not going to talk too much about Redis because it's third day. I'm pretty sure you know all of this. So Redis is open source, in memory, can be used as a database, primary replica architecture, provides high availability via Redis Sentinel, automated partitioning with the Redis cluster. Which set of operations of this all, I don't know, I'm a developer, right? I'm first developer. Of this all, one thing I'll tell you, Redis data structures. Redis data structure, I don't mind like the operational wise, like, people will take care of it, or Redis enterprise, or somebody will solve that problem. First, what is your problem? As a programmer, what is your problem? So the beauty of Redis data structures is every programmer, if you have a computer fundamentals, if you work with the data structures, That's what it is. You are directly working with the data structures. That's what the beauty of Redis. That's why I cover more on the data structures. So at very high level, you have strings, sets, hashes, lists, sorted sets, and hyperlog logs. And I don't need to explain you guys about like what these things. Whatever basic semantics, like a sets what are sets? Like unique elements, strings, hashes, right? You can look up by the hash code. So the same semantics on Redis as well, right? Redis deployment options. So you have 3 deployment options. One, it's a very, very, very simple, like 5 minutes thing, is simple master and like a master slave, or master and replica, sorry. Master and replicas. So that's how we started first. 1 master and 2 replicas, right? And if you don't implement on any auto failover, right? If master goes down, you have to promote a slave as a master with few commands, right? I'm not suggesting that, but that's one option. That's how we started. The second one is Sentinel, a little bit. Sentinel is, again, a quorum-based. It's a monitoring agent. It monitors all your 3 components. If master goes down, it promotes the secondary as master, okay? That's, again, 1 single master. All writes goes to 1 master. Now, let's say if you have a throughput requirement where you need to handle more requests, right? So for few requests, I think like 1 master is enough. 1 master can handle that load. But if you wanted to scale that, if you wanted to add more masters, that second model is not going to support you. So you need to go to the third model, which is a cluster model. It's a cluster model is, again, this has a multi-sharded model, where basically you are now saying like, okay, range of my keys, send it to 1 shard, range of different range goes to the different shard. Based on that, let's say if you have 1,000 hash keys, like 1,000 bucket keys, right? Then you say like if you have 2 shards, 500 keys goes to 1 shard, and other 500 keys goes to other shard. If you add 1 more shard, it's by 3, like 1, 2, 3. So then you have every master or every primary has the secondary just for the failover case, okay? Now, let's talk about Redis use cases at eHarmony. The very, very first one, most of you guys know Redis as a session store. That's how we started. We know that like when we evaluated session store, we did the benchmarking with five other data stores or caches, and then nobody came close to Redis, right? It's a sub-millisecond response time. So we go for, that's how we started Redis. And up until that point, we only thought that like Redis is a cache, because everybody was saying about like Redis is better than Memcache. Oh yeah, they're Memcache. Okay, but Memcache doesn't have the, what is that? Replication, Memcache doesn't have the persistence, or what I can say, snapshotting, right? So then that's how we choose Redis. And then once we started exploring Redis, we found more use cases with the Redis, and it has the persistence, it has the cluster, and it's stable. That's how we extended it to the other use cases. So at very high level, I think I already explained to you about this thing. User logs in, we create a token, which is called an access token and refresh token. Access token is a short-lived. Probably it's like, I would say 2 days or so. And then once that access token expires, you can take that refresh token, you can generate the next access token. Like that, you can, it's just like if you talk about keep me logged in kind of feature, where unless that refresh token expires, if you don't log in for so many days, it keeps rotating. Redis as auth store, it's a simple strings key value based store, token as key and auth object as value. And we have to have the TTL, so that's why we choose like simple string based one. Refresh has longer TTL. Redis client library, I mean, we are Java shop, so we use Spring Data heavily, and it is working really, really well for us. So we don't see any problems, so we keep using Redis, right? So Spring Data uses Redis as client library. And leveraging the Redis Labs replication, we have 2 shards, and like total 4 shards, 2 primary and 2 secondary. So at very high level, client configuration is like that with Spring. Operations, you can say like, Redis template.ops for value, and you can set with the TTL. And Redis CLI, I don't know how many people, I mean, at dev environment, you go and play with it. In production and QA environment, they don't give you access. They'll lock it down, but that's a nice thing to play. So that's what it is. I mean, right now it's a little bit more than that, like as I can say, like 200,000 calls per second. It can scale up to 500 calls per second, per minute, and 500,000 calls per minute. And then if it doesn't scale, we can add more. As you can see, our response time is sub-milliseconds, 0.05 millisecond, come on, right? And write latency. So for most of the stores, achieving both read and write latency is really, really hard. Either some stores are optimized for reads and some stores are optimized for writes. If you take Cassandra, HBase, and all these things, they are optimized for the writes, right? And some stores like MongoDB and all those things, they are heavily optimized for reads. This Redis, because it's in memory, it's optimized for both reads and writes. So that is through App Dynamics. It's not only monitoring the latencies at the Redis layer, because you have the network, you have the client connection pool and everything. It's always better to monitor the application layer. So even at application layer, you can see that 0.5 milliseconds to pull that data. So there are other things involved here. Data deserialization, that's the enemy for any Java application. It's not just like what you're bringing, but after you bring it, how much you're bringing, how much deserialization involved, what is the deserialization cost. You have to think those things as well. Next use case is Redis as matching user store. This is really huge. So by far, this is our biggest store for now. I think like we're going to migrate more things, but this is the biggest store. So what does it do? As I explained you about matching system, right? Our matching system, it has both offline and online. Let's talk about online first. So user sign up, user completes the questionnaire. Once you complete the questionnaire, guess what? User first goes to the My Matches page, okay? So for like a catalog-based systems, when you go to the catalog, they are there. You just get it. But here, our catalog is matches. Somebody has to work to generate the matches. There are so many things involved to generate a match. Once you complete your questionnaire, event goes that like, hey, user completed the questionnaire. Now, I need to take all your data and I need to find suitable pairings by searching our database. There are billions of data points. Among that, I need to find 10 topmost people, compatible people for you. And that has to happen in milliseconds. Because once you go to the My Matches page, you're not here to complete the questionnaire, right? You're here for matches, right? When you go to the My Matches interface, you're like, hey, we are working for you. We are working for you. No, you're not going to stay there. First impression is the best impression. We have to serve the matches by the time you landed on the My Matches. That we call it as a time to first match. That's very important. Which means when you complete the questionnaire, we need to pull all your data. We need to create pairings for you. And we need to score pairings for you. And we need to see who's compatible. We need to run the affinity model. Whatever I explained to you before, I need to run all these things, create the matches, insert into the system, and propagate wherever it's supposed to go. And then display those matches. So that's called first time. The second one is, that's where Redis is helping us. The second thing is offline data model, offline system. That the offline system has to go through these millions of users. We run it in different regions and different times. It has to go through these millions of users and pull their data. And then at scale, we have to map them. And then we have to score them. And then finally, we have to run all these models, matching compatibility models, affinity models, and then distribution, right? How we do all these things? If I have to go and join the data and pull it from the different data stores. No, that's not what we do. What we do is we store aggregated data, denormalized data in Redis. So matching user service is responsible for that. So what we do is we store user profile data, user questionnaire data, and user activity. How many times user logged in? At what times user logging in? How much communication he's getting or she's getting? How much communication user is sending? Is it extrovert, introvert? You need to know all these things because every single detail is important. For example, you upload a photo. Photo has so much information. We run through our face spots algorithms and we extract the face spots like you have a beard or you are wearing the eyeglasses, are you on the beach, are you somewhere else, right? These are all data points. We run through all these data points and generate. What we do is, so Redis, okay, so let's talk about like how we did it, right? In Redis, we are using the hashes data structure. You have user ID, and then you have your different sections of your data as your secondary key, like for hashes, right? We say like user, activity, profile, communication, your features, photo features or photos and all these things. And this is all stored as protobufs, Google protocol buffers, because this data is used in so many places. This data used for our modeling systems. Modeling people, they take the dump of it and run in the sparking cluster to train the people. This data used in our matching system, which is also Hadoop-based system, that is also in the protocol buffers. So we use the protocol buffers. Protocol buffers not only gives the compaction, but also it helps us when we run the models. So next one is, again, we are leveraging the Redis Labs cluster with 6 shards, 3 primary and 3 secondary, and leveraging the Redis flash storage. At very high level, this is what we do. I'm going to talk about few things here. You have pipeline. I'm pretty sure you might have attended other Redis sessions. The pipeline is basically if you wanted to execute multiple commands at one go, you can use the pipeline. You can also use a watch. For example, now you have user and so many sections of data, right? We have something called the full update, where basically, hey, go and refresh this user data, go and get it from different services, refresh. That's called the full refresh. Don't need to worry about it. Let's say if you want to do the partial update, right, of one section, which is also you can do it because like Redis is single threaded, it has atomic operations. But let's say within that particular section, I wanted to update a property. Let's say I have like 5 properties in my activities proto. Now I need to update one field. Unfortunately, you don't have any support for that in Redis because in Redis you're storing it in the byte, right? I need to extract that value into my service and then I need to update that one field and put it back. So the problem with the Redis is you don't have any locking mechanism, right? So now you can use this watch where you pull that object, dirty that, insert it. If nobody's using it, you can commit it. Otherwise, you need to retry that, right? So that's what watch operation is about. And at the end, like I mean, we implemented our own serializers, deserializers to serialize from byte array to protocol buffers. Second use case, Redis as badge store. So as I explained you before, like you can see those my matches count, messages count. What if these notifications are? That's what drives users into different features. We say like, hey, 10 notifications pending for you. 10 people try to communicate with you, or like 5 people uploaded photos, or 5 people updated their profiles, so that they can go and navigate to that particular page and see what the updates are. So these are all temporal data. Once you view a notification, we need to wipe it off, right? If you want actual counts, you can go to the service which is responsible for that. For example, your communication, right? Somebody sent you 5 messages, or 5 people sent you a message. We maintain that state whether somebody read or unread that message. That state is in the communication store. But you got 5 messages, that badge is stored in the badge store. Again, we leverage Redis for that. It's a Redis hashes. You have key as user ID, and then the secondary key, which is a hash key. That is a different sections of your badges, like a photos count, matches count, activities count, like that. So again, here, interesting thing to notice is H increment by. So even in the hashes, you can use atomic operations. Like that is beauty about Redis. I like data structures. I like atomic operations. It's a single threaded. You can leverage that. So you can say H increment by. You can use the primary key and the hash key, and it's just increment. So increment, you can call if you wanted to decrement. You just negate the value, it will decrement automatically. So here we are still using our Sentinel based solution. We have to add to migrate to Redis Labs, but if it is not that critical, you can operate on Sentinel as well. It's not that bad. I mean, we haven't seen any problems, but it is not as reliable as Redis Labs cluster, and also it can't scale. As I said, like it has one problem. You have a single master, right? So we are using Sentinel. Those are the few commands, like how it elects the master and all that. Next one, as Redis has speed store in Lambda architecture. Let me just, I think there's only one slide. We had a problem where basically one store, right, when we are generating millions of matches, which means we have to insert millions of records into one store. So when we are running these match models, or like a matching system, the front-facing services used to suffer, like response times, because it's like a burst of writes. Writes are, you can scale reads as many as you want, but writes, it has certain limit. So then we chose HBase. HBase for it's good for writes as a batch store. And then we choose Redis at the speed store. It's called Lambda architecture, and in the big data side, people pretty familiar with the Lambda architecture, but we implement it in the online system. So what happens is when user writes something, we write into Redis immediately. We store that for up to 12 hours. And then we emit an event. That event goes to Kafka. And then service pulls out of the Kafka, streams out of the Kafka, and updates the HBase. When user asks for it, they always need consistent data set, right? You get your batch view from HBase, right? Probably doesn't have recent updates, and you pull your recent updates from Redis, you merge them, and serve the data. Now you have fault tolerance. If HBase is not available, you have your Redis. You're not impacting anything. Your communications are going through, even though your primary data store is down. So it is good until up for 12 hours. If you can't fix it for 12 hours, you can increase the TTL of Redis. We haven't seen this problem, but it helped us getting the consistent read time, consistent latency. You don't need to worry about our batch runs. Next one is Redis sorted sets for security. So this is another interesting use case. We used to have these bot attacks. Pretty much everybody will have it. API abuse, I would call. People just randomly just target one API. They don't get anything because it's behind authorization. They just slam. They take one token, they slam, or they just slam the login endpoint. They slam different endpoints. So that's called API abuse. So we have to protect those things, right? One, if you are at really high level, there are DDoS protections, right? But it's not that high level. They are below threshold, but they might impact the system, or they might steal your credentials, like a brute force attack, where basically I have list of emails. I'll just randomly send password and see out of 1 million if I hit one, yeah, right? So to protect all those things, we have these different layers of security. This is the not only thing we do. We have WAF, we have various other security protections, but this one is helpful for API abuse, right? What we do is from CDN layer, from gateway layer, from the different layers, we collect all the logs, stream through the Kafka, and we have the Spark jobs. It's a different windows. I don't know how many of you are familiar with it. So Spark streaming has this window concept. What it does is 1 minute, 5 minute, 1 hour. We pull the data, we aggregate by IP or use agent or a bunch of other things, and we push the aggregates to Redis. That's where we use the Redis sorted sets. The sorted sets, what it gives you is the top elements. If you can ask for hey, give me range of queries, give me top abused IPs, give me top abused user agents, and you can block them. Okay? So how do we do that? Again, we are connecting from the Redis, leveraging top anomalies to find the top anomalies. Top n anomalies, we are finding the sorted sets. Single-threaded atomic operations are also helping here. Leveraging Kafka window operating from streaming, leveraging Redis Sentinel for auto-file over. So these are operations, G-set operations with the Java and Scala. We are using the Scala version here. This is just one API. Was before and after we implemented this thing. Before we implemented, you can see those spikes. It's annoying. They're not going to cause Redis to fail over. But it's annoying. We have alerts. Alerts triggers. Hey, somebody is some API got these many calls. I don't know whether it's a business impact. I don't know it's a real or not real. So to avoid this, we put this, and that's the result. And then Redis pubs up for configuration. This is another interesting use case. It's not in production yet. It is in beta. It's working fine, but it's not in production. So what it is, our product tries to do so many testing variations. It's called ABN or whatever. In the microservices architecture, problem is those are stateless, right? But in order to improve the performance, you have to put some near cache. Problem with the near cache is they are inconsistent with the other caches. You can set up some things where basically replicate between the caches, but the problem is that is only, I mean, if in the polyglot environment, it's very challenging to use such kind of replicated caches. So here, typically, let's say user experience, right? So we wanted to roll 50% of a new screen, like a new feature to user. So I give 50%. When I increase 50%, user comes into one node. Let's say I have a near cache with a 10 minutes TTL, right? You come to one node, and then that node, TTL expired, you pull the new value, and you give the new screen or new feature. And user again asks for it. That request doesn't go to the same node because it's not sticky. It's like stateless, right? It goes to another node, and that another node, if that another node doesn't have that value, then you are giving a different screen, right? That's a problem. So how do you solve that problem? So there are so many solutions, but one solution we come up with is a Redis pub sub. When we update that config value in our config service, so we publish to Redis, and then the nodes will consume off of it and then update it. So it's available right there. And many more use cases. I can't cover all those use cases here. We use it for rate control. It's an inline rate control where basically what I explained is the offline rate control, right? We are reacting, but this is a proactive, like as and when you are requesting for something, I can see how many requests you are making, and then based on that, I can give you different status code saying that that our applications understands that, hey, you are making too many requests, like slow down, right, kind of. And also we have other use cases we are planning to migrate to the Redis. At Redis Labs, we are using this is our QA cluster. Don't take the numbers. We have bigger clusters, as I said, like large data sets. This is our QA cluster. So it's very high level. You can create multiple databases. It supports multi-tenancy. It's easy to configure, and it's very stable for us. Redis monitoring. The top one is Redis Labs Redis monitoring. You can monitor different metrics, and you can set the alerts thresholds. The bottom one is for the open source. For open source, we have App Dynamics. We are using App Dynamics internally. So App Dynamics has extension, but every APM has its own extension. And also, you can use the Graphite. There are a few plugins for that. You can export it to Graphite, and So basically, set up these monitors and set up the alerts and react to those alerts, right? Redis modules and mix. Redis, not just the data structures. Now, another thing is Redis is working on all these add-on modules, which is very important for any NoSQL store to cater different use cases, right? I don't want to, as I said before, I don't want to end up creating 10 different data stores in my environment because one data store is not supporting a small thing, which is not primary for us, but it's good to have, right? So these modules will help you doing those things on top of what it is already doing. With that, I have 2 minutes left for questions.
Thank you. It was very clear and insightful. So how do you improve the algorithm for the matchmaking? Do you use machine learning? Do you consider using machine learning?
We have been using machine learning for a long, long time. So all your compatibility models and affinity models are machine learning based. How do we do that and I would tell you, we have 18 years of experience. Machine learning is not about just like I have a models. It's about how much data you have and how much you are learning from it and constantly learning from it and improving your models, right? Whatever data we have, we call something as success couples. It's not only just making the matches, we need to find out who is successful. I would tell you off the record, I think we did the survey, there is about we are cause for 4.5% of the US marriages, United States marriages. That's a pretty significant, right? So that's what it is. We track the success. We track the success of our algorithms, right? We constantly modify it, right? When we started this service, there were about 250 plus questions, right? It used to take 1 hour for you to complete before even taking the service. Now it's down to 100 questions, right? So we have machine learning. We have about 20 plus affinity models in active. We have compatibility models. We are very heavy on machine learning and then big data. It's been a while. We didn't start it recently. I started in eHarmony in 2010. It's there when I joined. That is the crux of it. That is the main thing for us.
You just need to track the divorces as well.
I'm sorry?
The divorces, you also need to track that out.
For us, I mean, we can't track much of divorces because they don't talk about it, but there is an offline study and it's very less compared to other things. You know why it is, right? Because we don't give you a chance to just go and browse people. It's just like we match carefully, right? And then people are also that mindset where they come here for the long-term relationship. I'm not saying there are none, but yeah. Wait, one more.
Can you talk about a time when Redis failed and how'd you fix it?
Oh, sure. Redis Enterprise, I don't see anything because if master fails, slave kicks in. Very first thing, it was not in the production. We just launched it. It's in the dual write mode, master slave, and then master failed to promote the slave. It took a while because we implemented our custom failover where at a VIP level. We said a master call goes to the VIP. I said go to this master and I need to update from master to a different node. And then funny thing is you need to go to the configuration. You don't need to restart, but you need to go there and say hey, you are now master. Redis CLI, now you are the master node. It took about 15 minutes. That's when we said no, we are not going with this. We went with the Sentinel. Even with the Sentinel, we had one hiccup. That's not for the primary system, but I think the badge stores. Unfortunately, we upgraded from 2 point something to 3 point something. There is a mode, disable mode, or writes disable mode that has been disabled. And then Sentinel is trying to, how Sentinel works is it says okay, you are master now, you are down. Now I need to promote somebody as master, right? So now I go to that configuration, I say hey, now you are master, right? And then you take him out of it and tell other slave to that hey, here is your new master. This is our configuration change. When it's tried to change the configuration, since it's in protected mode, it didn't happen. So it took a while, I think half an hour or so to realize it. We have to go through the logs and say, oh, Sentinel is not working because of this, because we didn't upgrade the Sentinel. Okay, let's upgrade the Sentinel, right? That's a good lesson for us. Then we moved to Redis Lab. Oh, no. The Sentinel business, because Redis is one side, Sentinel is one side. They both have to be compatible and all these things. If for your mission critical, you have to go through Redis Labs. That's how we ended up in the Redis Labs. But again, it didn't cause any production outage or whatever. That answers your question, I believe? Okay, good. Yes, sir.
Why did you say instead of the open source Redis, instead of just putting everything into Redis Labs?
Redis Labs? Sure. We started off with the open source Redis, and it worked well for us. And then later when we realized that I need this scaling aspect because I can't scale, and also your persistent storage. Right now, if you have the open source, if you don't use the cluster open source, there is no overflow. You have set memory. That memory will be replicated or snapshotted, I would say, snapshotted. But if once you exceed, you have to start evicting. But if you want to use it as a store, you want to have a persistent store. So hey, this is my memory, but if overflow, put it in my flash, right? So Redis on flash is really good. That helps you on top of these operational aspects. Why don't you use Redis Labs for everywhere? So again, I have small things. They might not be that important. And also, you have some associated cost as well, I would say. So that's why. But I would say if you can afford, just go for it. And I don't think it's that expensive, to be honest. Yeah. Good. Thank you, guys.